From the given shear diagram in the figure shown, we are tasked to determine the value of the uniform load on the left side and the value of the maximum moment in kilonewton meters. Now to solve for the first problem, the value of the uniform load on the left side, notice that the shear is positive, which means we expect this uniform load to go upwards. And it must induce a first degree curve that has a value at this point equal to 20 kilonewtons. Therefore, we expect the area of this uniform load to be equal to 20 kilonewtons to produce this certain shear. So we have our uniform load W with a length of 2 meters, solving its area, that is its length times the height of W, must equal to 20 kilonewtons. We get W equals to 10 kilonewton per meter. That serves as our first answer to this question. To solve for the maximum moment, we consider our moment diagram. Now from this point to this point, that is a length of 2 meters, we can solve for the moment from this segment by getting the area of the shear diagram. That is the area of the triangle equal to 1/2 times the base of 2 meters times the height of 20, which is equal to 20 kilonewton meters. So that it would increase in such a way like this. Because the shear is 0 at this point, the slope in this moment diagram must be horizontal line, and it would increase up to this point that has a value of 20 kilonewton meters. Next, for this area right here, notice that these two right triangles are equal because each shares the same height, the same angle, and the same angle right here. Therefore, this side, the length of the base must be equal. Therefore, we can divide 0.5 by 2. So these two triangles have a base length of 0.25. Now we can solve for the area of this triangle here, that is 1/2 times the base of 0.25 times the height of 20. That's 2.5. Therefore, we add this up to this moment right here, which is a value of 20. Therefore, this moment right here would increase a value of 22.5 kilonewton meters. Let's write down this value. And because this area right here is negative, it will decrease our moment diagram by a value of this area of the right triangle. That is 1/2 times the base of 0.25 times the height of 20 kilonewtons equal to 20. We go back to 20. And then since this area right here is also negative, therefore this point right here in the moment diagram will decrease. Now to solve for the length of these two triangles, notice that it shares the same height of 20, same angle of 90, and the same angle right here, which means that the length of their base must be equal. Therefore, we can divide 4 meters by 2. So this base of these two right triangles is equal to 2 meters. Now we can solve for the moment from this point to this point. That is 20 minus 1/2 times base of 2 meters times the height of 20. It will decrease back to 0. And then it will increase because it has a positive area with a value of 1/2 times the base of 2 meters times the height of 20. So it will increase back to 20 kilonewton meters. And then this area right here and this area right here are the same right triangle. Therefore, they share the same height and the same base. So this 0.25 divided by 2, that is equal to 0.25. So 20 plus this positive area of 1/2 times the base of 0.25 meters times the height of 20. It is equal to 22.5 kilonewton meters. And this minus this area here, which is just basically equal to this area, it would decrease back to 20 kilonewton meters. And for this area right here, since it's negative, we subtract 20 by this area of the right triangle, that is 1/2 times the base of 2 meters times 20 equal to 0. So it will decrease back to 0. Now we can solve for our second problem. the maximum moment in kilonewton for this given shear diagram, that is equal to 22.5 kilonewton meters. And these are our final answers.